A confidence interval can be computed for almost any population parameter. The confidence intervals considered in the last few sections are for the mean of a population where the standard deviation of the population is unknown. Three other confidence intervals involving means are confidence intervals for the mean of a population when the standard deviation of the population is known, confidence intervals for the mean of the difference between matched pairs of samples, which will be explained in a moment, and confidence intervals for the difference between the means of two separate populations. A detail of terminology here is that it is conventional in describing these confidence intervals to refer to known variance rather than known standard deviation. Standard deviation is simply the square root of the variance, and since both terms describe the variability of the population, variance is just a different word to use for saying whether the population has some known variability. As described in a previous section, starting with a sample like this one, the default output of the mean CI function is a confidence interval for the mean of the population with the assumption that the variance of the population is unknown and so is estimated from the sample. This result uses a formula involving the sample mean x bar, a critical value t star, and the standard deviation s and size n of the sample. The value of t star is based on the student t distribution, and those values can then be inserted into the formula to get the same result as the result from the mean CI function. Confidence intervals for the mean of a population when the variance is known are much less common. The mean CI function has an option called known variance, which is used for entering the value of the variance. This shows mean CI used to give a confidence interval for the sample entered earlier, but with the assumption that the population has a known variance of 4. This result uses a formula that gives the endpoints of the confidence interval in terms of the sample mean x bar, a critical value z star, which is based on the normal distribution rather than on the student t distribution, the sample size n, and the known standard deviation sigma of the population. This input gives the value of z star for a 95% confidence interval. This input is much like the input that was used earlier to get t star based on the student t distribution, but when the variance of the population is known, the appropriate sampling distribution is a normal distribution rather than a student t distribution. That value can be inserted into the formula to get the same result as the result from the mean CI function. Standard deviation is the square root of the variance, so a variance of 4 corresponds to a population standard deviation sigma of 2. Matched pair data is data collected from pairs of similar individuals or data collected from the same individual at different times or in a different way. For example, this diagram illustrates matched pair data collected for 7 individuals before and after some change. The individuals could be 7 fruit trees, for example, and the data could show the amount of fruit produced by each tree before and after pruning or before and after adding nutrients to the soil. Matched pair data is useful because it provides a way to separate the effect of some change, such as pruning or the addition of nutrients, from any variation between individuals that is already present in the population. The effect of the pruning or nutrients can be measured here by subtracting the before and after numbers for each tree. Although the original data is a pair of lists, or it could be a list of pairs, the data of interest is the list of differences between the before and after measurements for each individual. A confidence interval for the mean of the population of differences can be computed as before using the mean CI function with that list of differences. So the confidence interval for the mean difference for matched pairs is computed just like a confidence interval for the mean of a single population. Confidence intervals for the difference between the means of two separate populations are a bit more complicated and will be covered in the next section.